Okay, so we're going to practice graphing with the derivative. So this is the first day we're going to do this. So for each question, for each function, we're going to find equations of vertical, horizontal, or slant asymptotes, intervals where the function is increasing or decreasing, intervals where the function is concave up, concave down, coordinates of the relative maximums or relative minimums if they have it, coordinates of the points of inflection, x and y intercepts, and then we're going to graph it. Okay, so here we go. This very first one. Now, um, first thing we're going to do is we're going to find the zeros or the x and the y intercepts. So I set this equal to 0 and I factor. And when you factor, you take out the x squared, which leaves you with x minus 6, which means our x-intercepts are 0, 0, and positive 6, 0, which means my y-intercept is also that 0, 0 point. Okay, so that's the easiest part, x and y-intercepts right there. Okay, so now, asymptotes, well, this is the cubic. It doesn't have any, so there's none. No asymptotes. Okay? Now we move on to increasing and decreasing. So to find where a function is increasing or decreasing, we use the first derivative test. So we take the derivative, which is 3x squared minus 12x. We set it equal to 0. Again, just like we did for the zeros of our original function, we factor. We take out our greatest common factor. We get x minus 4, which means our zeros are x equals 0 and x equals 4. Okay? Then we create our number line, our first derivative test. We put our 0, we put our 4, those are our zeros. Then we test it. So we pick values. So I'm going to pick negative 1. When I plug negative 1 in here, I'm going to get positive. When I plug in 1 into my first derivative, I'm going to get negative, and I'm going to plug in 5, and I get positive. So these are the intervals where my function is increasing or decreasing. Okay? So at this 0, my function on this side is increasing. Afterwards, it is decreasing. Here, my function is decreasing to the 0, and on the other side, it is increasing. So this test also tells me my relative maximums and minimums. So let's start by putting in our increasing. Well, our function is increasing where the derivative is positive. So that's this area here. So it's increasing from negative infinity to 0 and from 4 to infinity. That's where it's increasing. And it's decreasing in between 0 and 4. So those are my intervals of increasing and decreasing. At the same time, I can also realize that at 0, I have a maximum, and at 4, I have a relative minimum. We'll figure out the y values in just a minute. Okay? Now, second derivative is what's going to tell me my concavity. So I need to find the second derivative. Well, I already know what the first one is. So the derivative of 3x squared minus 12x is 6x minus 12. Again, we set that equal to 0, and we get x equals to 2. Okay? Now we do the same thing with the second derivative test. We put 2, we put our 0, now we test it. So we plug in values on either side. Well, I'm going to plug in 0, that was the easiest, and I find this side's negative. Then I'll put on this side and plug 3 and find this side's positive. That's telling me my concavity. So it's telling me that on this side, my function is concave down, and on this side, it's concave up. Okay? Which means my concavity here, it's concave up from 2 to positive infinity, and it's concave down from negative infinity to 2. Okay? And it also is telling me that this 2 is my point of inflection. So I'm going to put 2 there. So now, to find these coordinates, I have to plug into my original equation. So I find f at 2. So when I find f of 2, that is negative 16. So that's my point 2, negative 16. Then I plug in 0. And when I take 0 and I plug into my function, I get 0. So f of 0 is equal to 0. And then I need to find f at 4. And when I plug in f at 4 into my original equation, I get negative 32. So this is negative 32. Okay? So now that I have all of my information, I can start graphing my function. So I start by plugging my coordinates. So my x-intercepts, 0, 0, 6, 0. Well, my y-intercept's 0, 0 as well, so I don't have to put that. Now my x values are really big, so basically what I'm going to do is I'm going to consider my y values by 10. So this is going 10, negative 10, negative 20, negative 30, negative 40. So basically 4, I'm going to plot my relative minimum, 4, negative 32, which is basically here, and 2, negative 16, which is right here. So there's my point of inflection, and I'll change that to purple so you can see it. That's my point of inflection there. Okay. Now it's the cubic, so, and I know how it looks from my concavity. On this side of 2 it's down, on this side of 2 it is up. So you can see here, this is my cupping up. So this part looks like this. On this part it cups down from my concavity. And that's the way my function looks. And if you remember from pre-cal, this 0 right here, since it's multiplicity 2, it bounces, and that's why it looks like that. So this is how we put everything together. This is pre-cal, this is algebra 1, algebra 2, and the first and second derivative test all put together. So basically we get a very, very good picture of what my function looks like. So this is how you graph using our first and our second derivative.